So in this class I want to talk a little bit about momentum and introduce momentum. So momentum is defined as being the product of the mass and the velocity of an object. The product of the mass and the velocity of an object. The product of mass and velocity. We're talking about velocity. Remember we said before kinetic energy is a function of speed. So when we're calculating kinetic energy, we're interested in speed. When we're talking about momentum, we're talking about velocity. So the direction is important here. It's a vector quantity directed through the body in the direction of motion, and this is kind of my formula. This says momentum is equal to mass multiplied by velocity. The letter we usually assign to momentum is that lowercase p. Why p, I have no clue, but p is equal to mv. Momentum equals mass multiplied by the velocity of an object. Another important thing we talk about is something called impulse, which is defined as being the change in momentum. Impulse is change in momentum. Okay, and we're going to talk a little bit about momentum in this lesson. So I've just done out a table of values here. I've got momentum, I've got mass, and I've got velocity. The units for momentum, you know, if I think about my units, well, momentum is defined as mass times velocity, so my units would be my units for mass, kilograms, multiplied by my units for velocity, meters per second. So kilograms, meters per second, that's absolutely fine as a unit for velocity. Okay? But also, we could write that as newton seconds. Not newtons per second, n times s newton seconds. Okay? Which is my unit for force by my unit for time. Okay, let's just think about that for a second. If I take force, which is mass times, if I take force and I multiply it by time, what I get is mass times acceleration, which is force, by time. And if I think about my units for that, my units for mass are kilograms, my units for acceleration are meters per second squared, and my units for time are second. And what we have here is a kind of a cancellation. So we get kilogram meters per second. That's force by time, so I can think of that as newton seconds. So to find p, remember p is equal to mass times velocity. Momentum and velocity are vector quantities. Mass is a scalar quantity. And as always, you know, you should think about that. It's one of these relationships we see all the time. Mass is equal to momentum divided by velocity. Velocity is equal to momentum divided by mass. Momentum is equal to mass times velocity. Three versions of the same kind of formula exist. So how do we calculate momentum? Well, it's mass times velocity. If the mass is 7 and the velocity is 21, the momentum will be 7 times 21. That's 147 newton seconds. If I'm given the momentum is 38 and the velocity is 5, and I want to calculate the mass, well, the mass is momentum divided by velocity. 38 divided by 5. 5 into 38 goes 7 times. Remainder 3/5 or 7.6 kilograms. How do I find the velocity? If I'm given momentum and mass, well, velocity is momentum divided by mass. 45 divided by 20 will give me my velocity. 20 goes into 45 twice. Remainder 5. 5/20 is a quarter, which is 0.25 meters per second. 2.25 meters per second. But I'm dealing with a motion, dealing with an object moving kind of in this direction, I hat plus 25 j hat. It's no different, you know, to find the momentum, we just multiply the mass by velocity. 7 times I, 7 I hat, plus 7/20 is 140, and 7/5 is 35, that's 175 j hat. To find the mass, how do we find the mass? Well, we'd use this version. Mass is equal to momentum divided by velocity, momentum divided by the velocity, and that will equal to 2, because 2 3s are 6 and 2 13s are 26. How do we find the velocity? Well, velocity is momentum divided by mass. 22 plus 12 divided by 4. Well, 4 goes into 22. 5 times remainder 2. 2 quarters is 1/2, or 5.5. That's my I hat component, plus 12 divided by 4 is 3. So, momentum is equal to mass times velocity. That's what you've got to remember. Okay, I want to think about this quantity here. This is what we call impulse. An impulse is defined as being the change in momentum. And the change in momentum will be the final momentum. Subtract the initial momentum. You know, the change in any quantity is the final value for that quantity minus the initial value for that quantity. So my impulse here, final 7 minus initial 3, my impulse here would be 4 Newton seconds. Okay, and again, just like before, impulse is equal to final momentum minus initial momentum. There's 3 ways you can change the subject of that formula. I could say that means that the final momentum is going to be equal to the impulse plus the initial momentum, or the initial momentum, that should be a hat there, the initial momentum, just changing the subject of the formula, is going to be equal to the final momentum minus the impulse. Okay, so 3 versions of the same formula. What am I looking here? I'm looking for final momentum. Well, final momentum is impulse plus initial, so 5 plus 38, that's 43. To find my initial momentum, well, initial momentum is final minus impulse, 45 minus 20, that's 25. I'm looking for my initial momentum, it's final momentum minus impulse, 2I hat plus 2J hat, minus I hat plus 25J hat, that's going to be 1I hat minus 23J hat, Newton seconds. To find my final momentum is my initial, this is my impulse, added to my initial momentum, impulse 3I hat plus 13J hat, added to my initial 5I hat plus 26J hat, that's going to give me 8I hat plus 39J hat Newton seconds. And then finally find the impulse. Well, it's the final minus the initial. 5 subtract negative 1, that's 6I hat, 26 subtract 11, that's plus 15J hat. Okay, so that's momentum. That's how we think about momentum. And of course, impulse. Impulse is defined as being just the change in momentum. Momentum is defined as being the product of the mass by velocity. So get used to those things, get used to those formulas. Okay, momentum is mass times velocity, and impulse is equal to the change in momentum. And those things are in your formula and tables booklets, I'm pretty sure, so see if you can find them, dig them out. Okay,